97.5% of the time, you're going to flip some number of heads that's less than 60.
Okay, I understand what you're talking about, but that was confusing.
Did someone else explain?
I just look at it that like the area that's shaded right now, the area that's shaded in red, that's 95%.
Indeed.
So there's 5 more percent, and it's split up on either side, and because it's even, it's just what's 5 divided by 2.
So
you do 1
good.
minus
So
point.
that's saying the area to the left of this value is 97.5, right? But the area to the left, it's saying that in this distribution, where every x represents 100 flips, a sample of 100 flips, in this distribution, 97.5% of all the samples you could ever take. You flip 100 coins, you flip 100 coins, you flip 100 coins, you keep doing it, 97.5% of all those flips are going to be less than 60 heads.
Yeah.
2.5% of the time you're going to find something.
But the
more
reason
than
you have
60 heads.
0.975 is because you like subtracted 0.025 from 1 to like represent that 2.5% at the end.
Yeah, so I want 95 plus 2.5.
Yeah, I just want.
Other questions?
So then do we need to do the other side too?
So we need to do the other side too. So we can plug it in. So this is going to be Q norm
Is it going to be the same?
0.025 comma
0.5.
0.5 comma 0.05. So what do you get when you plug this in?
About 0.4.
About 0.4, and that should make sense because these things are symmetric, right? So if I'm going, if I'm at the center and I go, this whole thing is 95, so I'm going some distance over to the right. So what is 95 divided by 2? 47.5, right? So if I go like 47.5% to the right, here I'm at 0.6. If I go 47.5% to the left, 0.5 plus 0.1, 0.5 minus 0.1, I get 0.4. So if you're not using your laptop for something productive, you don't need it. So again, the interpretation here is saying that, so just, I shouldn't even be doing this because we should know it, but this area here is what? It's 0.025. And that's equal to P, the R code would be P norm, comma, 0.4, comma, 0.5, comma, 0.05. And the interpretation here is that 2.5% of the time, if the coin is fair and you're flipping it 100 times, 2.5% of the time you're going to get 40 heads or less. Okay? Alright, so now this is a test of my art skills.
Oh my god.
So this might be a little bit mind-blowing, but we'll do our best.
What did I say up there?
So assume this is the truth.
That's like when you get a 50 on your test, you're like, a 50 is like a 55, and a 55 is like a 60, so it's like, I got a 60 on my test.
Yeah. So here's the deal. Sorry, I wrote down some notes, but they're not really great. But so let's focus on this for now. Hannah, can you read what I just circled?
Used to find parameter we don't know.
Use to find parameter we don't know. So let's just talk, about what we've been doing. We've been talking about hypothesis testing. This is important. What is hypothesis testing? What are we doing? Alex, take us through. We're trying to go for it.
Trying to prove something that you believe in, or disprove or something.
Okay, good. Yeah, even better yet, maybe trying to disprove. We have some null assumption and we're trying to disprove it. But what is the null assumption? We've talked a lot about that. Someone describe that.
Like the least exciting thing we could think of.
The least exciting thing we could think of, good. And it's some assumption, and so we start off by assuming the null assumption that h sub 0, the hoe, we start off by assuming that that is the truth. And then we go through and we say, well, assuming that the coin is fair, if I flipped 87 heads out of 100, do I actually think that my assumption was right? This is what we've been doing, yeah?
Yes.
So now we're going to be doing different stuff.
But kind of related.
Definitely related, but slightly different. We're basically, instead of assuming that we know the truth, we are going to collect a sample. We're going to say, we don't know the truth, but what is it? And we're going to have some margin of error. So when they said 35% of people are worried about money, do they really know that 35% of Americans are worried about money?
No.
No, they just are pretty sure that it's close, plus or minus 3 percentage points. So here, actually, we'll do this problem in a second, but I'll put some blanks up here. I said, say we sampled 121 kids at Choate, and we find the average. What was something that we could find the average of 121 kids about?
Hours of sleep.
Average hours of sleep, thank you, Aiden, is equal to 7, okay? So we could go out in Choate's campus and we could sample 121 kids and we could find that the average amount of sleep they get is 7 hours. But are we totally sure that the average amount of sleep that all Choate students get is 7 hours?
No.
No. But so what we're going to assume is we're going to say, hey, let's assume maybe it's 7 hours, but now let's include some margin of error on that estimate. And so we're going to include, most often, kind of this 95% margin of error. We'll explain what that means in a second, but I'm going to say, I found an estimate of 7%, but I don't know that it's 7%, but I'm pretty sure that maybe it's between, like, whatever this is and whatever that is.
7%, 7 hours.
7 hours.
7 hours, sorry. So I found an estimate of 7 hours. I'm not positive that it's 7 hours, but I'm pretty sure it's between this margin of error. And again, we should definitely get conceptually that how would you decrease your margin of error?
By asking more people.
By asking more people, right? If you ask thousands and thousands of high school students, thousands and thousands and thousands, and they said they got 7 hours of sleep, well then you might say, I got an estimate of 7, and I'm pretty sure it's between like 7.1 and 6.9. But if you just asked like 10 kids, and you found that those 10 kids on average got 7 hours of sleep, well then you might say, well, I think it's 7, but since I only asked 10 kids, I have a pretty high margin of error, so maybe it's between like 4 and 10, I don't know.
So what would our standard deviation be for this?
So the standard deviation using to do this is going to be the same way we've done the standard deviation before. So we'll do an example here. Actually, should we do
How do you calculate the expected value?
26.
we have 5? No, we have 10 minutes.
10 minutes? What's the probability?
9. 8 minutes.
All right, so let's work backwards. I want to talk about using this kind of crazy thing and talk about what it means, but first maybe it will be helpful if we just do a problem, and then we'll get some numbers and we can talk about how to interpret them. So in this case, we find that the average hours of sleep for 121 kids is 7 hours, so find the 95% confidence interval. That's just saying I want to find the bounds here, such that this area, again, is 95%. So some information is missing. What information do I need to give you here?
Distribution.
Good. So I'll say S is some variable that stands for student sleep, and so I'll say that the standard deviation of my sample was how many hours?
2.
2. Maybe even, sure, okay, 2 hours. So therefore, what's the standard deviation of this sampling distribution? This is the distribution of like S bar sub 121. What's the standard deviation here? Sorry, Alex, what did you say?
It's root of 2 over.
So I take my standard deviation of one random variable, so it's 2. Good. Sorry, over what?
Over 11.
Yeah, over the square root of n. So I'll say sigma sub s over the square root of n, so it's 2 over 11. So it's 2 over 11, like 0.22, is that right? Yeah. So now that I know the standard deviation of this distribution is 0.22, again I can say, okay, Q norm 0.975, comma, what? 7 two, can you say that again for me?
7.43.
7.43. Okay, so now again, it's symmetric, so if I go 0.43 up, what's 7 minus 0.43?
6.57.
0.57. Okay, so that is not that hard. We just did a confidence interval problem. The only hard thing is really understanding what it means, which we'll talk about now. But we should kind of get the intuition.
So it's point 0.975 every time.
For a 95% confidence interval. So basically I'm saying, we'll talk about what that means, but the area in the middle between those two bounds is 95%. So if the area in the middle is 95%, then it's 95 plus 2.5. What's up, Alex?
Is that never gonna change, or can you change
So sometimes, as I wrote down here, we might make a bigger interval, so, and we have more confidence. I'll explain what that means in a second. Or I guess I could explain what it means right now. So,
If there's a bigger
I
interval,
could say-
would that be like 99%?
yeah, so, or what about like 99.9% confidence? Right, I could say, I'm 99.9% confident, I'm 99.999999999% confident that the true average amount of sleep lies between what two values? I'm almost certain that the average amount of sleep is
5,
true.
7,
6 and 7 hours.
So think more ridiculously. Like
0
I know
and
the average
20.
amount of sleep is between what?
0 and 24.
0 and 24, exactly. So I could create, essentially 100% confidence interval. Say, I'm 100% sure that the true mean is somewhere between 0 and 24, but is that really helpful to us?
No.
So I could say,
Obvious.
actually, that I think it's between 7.1 and 6.9. But I'm less sure that it's between 6.9 and 7.1. So 6.9 and 7.1, it's a smaller range, it's more precise, but as you can see, if we find this area, it's like you're less sure that it's in this range. So the smaller the range, the less confident you are. So you're giving a nice precise estimate, you're like, hey, it's pretty close to 7, but I'm not totally sure that that's true. Whereas you could say, I know it's somewhere between 0 and 24, who cares, but I'm positive that that's true. So there's kind of a trade-off between the size of your interval and the confidence that you have. All right, so going back to this example here, how wide was this range between the 95% bounds? Yeah, 0.2, right? So what's going to happen now, and we'll do some more examples related to this tomorrow after the quiz, is say you go out in the world, and let's not talk about polling, let's talk about like polling. So say I find in a poll that 55% support, who's our candidate?
Hillary. Very
So we'll
confused.
stick with Hillary. So I find that 55% support Hillary. So now,
I heard.
this is a bit statistically inaccurate, but here, kind of the 95% spread was 0.2. So here, if I go 0.1 to the right and 0.1 to the left, that's going to put me at, what's 0.1 to the right of 0.55? 0.65, and 0.1 to the left is going to put me at 0.45. So if I went out and I found a poll that said 55% was the truth, well then what I would do is I would say, okay, maybe 55% is the truth, so I'm going to center my bell-shaped curve at 55%, but I'm going to find this margin of error. I'm going to say, I don't know that it's 55%. Maybe it's somewhere between 45 and 65%. I could do the same thing if I did another poll and I found that 60% support Hillary. Well, where is my confidence interval going to range between now? Kat, what's going to be my upper bound on this confidence interval? So here I went from 0.5 to 0.6. Here I went from 0.55 to 0.65. So I'm going to go from 0.6 to 0.7. And I'm going to go from 0.6 down to